Let's now prove that f of x equals x to the n is an odd function if n is an odd integer. Well, this of course is the reason why f of x is x to the n is called an odd function in the first place. An odd function is a function that satisfies that f of negative x is the same thing as negative f of x. And when an odd function is graphed, there is a symmetry about the origin. Common examples of odd functions are, of course, sine of x and tangent of x, x to the n if n is odd integer. Also, something like f of x equals x over x squared plus 1. And you should convince yourself that that also is an odd function. And like I said, all of these have the property that there's a symmetry about them. They're not symmetric about the y-axis, but they're symmetric about the origin. Symmetry about the y-axis, of course, means that it's an even function as opposed to an odd function. To the question at hand, let's prove that it is an odd function when n is an odd integer. So the proof. Let's take a look at f of negative x. And that is equal to negative x to the nth power. And that's equal to negative 1 times x to the nth power. And since n is an integer, we have the property that this is equal to negative 1 to the nth power times x to the nth power. And because n is odd, whether it's positive odd or negative odd, negative 1 to an odd integer is equal to negative 1. So that's negative x to the n, which is negative f of x. And therefore, x to an odd power is indeed an odd function. And that is the end of the proof.